Hey, welcome early morning hustle. So let's get to work. Gonna go ahead and go to posit. I think it's automatically gonna show up. Yeah, it automatically starts like I noticed in the last video. um, so here we go. We worked with four cats. No, we did strings first, and then we did four cats. And hopefully you saw that there is a connection between the two. Um, and in class, we're going to I actually have time to talk about the two of them. Where in that, oh my gosh, in that when you're working with forecasts, you're dealing with factors, essentially a categorical variable or a categorical binary variable. Whereas when you're dealing with strings, you're dealing with strings or dealing with characters, and you're trying to manipulate or figure out, extract, extract, remove, replace text within the strings. So with that being the case, let's go ahead and move down to video 7, which this is video 7, done with advanced visualizations. Advanced visualizations with data transformations. So we've already learned some data transformation techniques previously. I wanted to concatenate or combine those techniques with some visualization, some advanced visualization techniques. We already have these packages. Not well, some of them we don't. But I'm only doing this so that you can like see where these functions are coming from. So ggplot2 is something that we're going to do with because we're doing some visualizations. Okay, we're going to be doing some data transformation, so therefore I'm going to use dplyr. We're going to then do some potentially pivots. I'm pretty sure we're doing a pivot. Tidyr, and then last but not least, we're dealing with some factors, so therefore we're going to be using four cats. Okay. So here we go. So it'll be nice if we just look at a data frame. So we're going to go on a little bit of a digression in terms of our data, just so we can get a better grasp. I'm going to run this so I can have access to these functions. Okay, so you can run that there, that run button. Put that way to the side. Okay, so then here we have these two tribbles. I'm pretty sure this is going to give us an error. That should we call it tibbles. And this is a format at which you can actually run the data. I mean, run your actual tibbles, where these are the column names, and then these are the corresponding data within the column name. So the tilde specifies the column, and then each row after that is an actual row. So when we run this, okay, we actually do get the data. That will throw an error. Because the function is called tribble. That's fine. So then here's the data for both of the data frames. Okay. So when we have data in this format, I'm pretty sure the question is going to ask you, there's two pieces of information. You'd want to essentially have it in the same data frame, or you would want to manipulate it depending on the situation. And so you're going to see why we would do such a thing in terms of our visualizations. So here we have the students' names, right? And we have the students' performances. So let's say, for example, I want to see how the statistics students compare to the bio students. We can do some transformations to do that, to be able to answer that said question, which is nice. Okay. And so let's talk about one element, pivot longer, in terms of the quizzes. So we can make this in the long format, where each row is going to have the different students, and another column is going to be the type of quiz, and then another column is going to be the actual score on the quiz. And again, the reason why we would want to do that is so that we can compare how Anna, Ben, and Charlie are doing in terms of major. So the columns are going to be quiz 1 and quiz 2. Okay. Quiz 1 and quiz 2. Okay. And let me run this, and I'm going to put an underscore df because did I do it before? I didn't. Okay, that's fine. I'll let it ride for this time. Let it ride. Okay, so when I run this, I'm gonna have. Can you guess the dimensions before I run it? I'm gonna try to guess as well. So let me look at this again. Store scores. It low-key should be. And when I say dimensions, how many rows and how many columns should it have? It should have 6 rows and I would say 3 columns. 6 rows, 3 columns. Run this. Oh, I'm wrong. What did I say? So it's I see. So I really love making mistakes, and I don't re-record, and I like to have the mistake being shown. I mistyped one of the quizzes, which is fine, and I think that it's important to see me make mistakes, not just to say that I'm human. Of course, I'm definitely human. I'm pretty sure everyone knows that, but how do I problem solve? And so I took a second, and I paused it, of course, the video, and I saw, oh, quiz one, and at least we got to see what kind of error that came about. I didn't spend too much time on this. We talked about pivot longer before, but again, we're still specifying the columns that we're going to select to be transformed. Okay, where is it? So long. Okay, that's going to be our new column, and then we're specifying that new column's name and the values that are associated with it. Okay. So now we can do a left join with this student long, okay, and then the demographics of the students. So scores long. Sometimes I wish I was in the source version of this because autocomplete would help a lot. So source long, and then I can get the demographics. Since autocomplete's not there, I'm just gonna put that here, and then I'm gonna join them by name, and then we get this full with student data. So one can even ask, could we have essentially done this by a full join? We could have done a full join. An inner join, I believe, would work as well. Let's just try that for, because you're matching on, it's common under both situations. So it's 6x4. It's still 6x4. So inner join will work as well. Okay. A right join we'll have to do that for now. So I'm gonna put it back as left join. And then from there, now we can do some visualizations with this information. Okay. Oh, so we can find the average score by, what does the question say? It says we can either find the average score by by major, or by student. Let's just do it by major. Okay, MAJ, major. And when we run this, okay, with the average score by major, again, there was only 2 majors. We got statistics and biology. And so when we see this data frame, we get the average score for each major. All right. So that's that. And we would want to, let me see, boom. We can reorder by major. So I believe it's going to do the smallest first. So what I'm going to do is average score, and I'm going to do it twice so that you can see what happens when I don't use the factory order. So this factory order is essentially sorting out the actual plot based on the order of the average score. So if I do this, run, it's showing that biology is higher, right? But if I don't do this, I think the default would automatically be by ABC. I think it's going to be ABC order, and I think it's still going to be biology. But let's just see. Make sure get those same results. AES, so it's going to be this one I want to get rid of. So I copy this and then just put major. Because the bottom, it starts from the bottom up. That's what it is. Okay, so it's going from major to biology. So the bottom, it's the first it's stacks and then statistics, and then if you do it by order, biology's on top. Okay, that's cool. Okay, so then from there, we can learn this new technique within within ggplot called facet wrap. So it allows us to have containers of where the data is actually stored. So if I do this by major, I'm gonna have a column by major in terms of their performance. Is it major? Pretty sure it's major. Okay, by major. Okay, so here you have the biology student, right? Ben, he's by himself. Okay, that's cool. Then you have the stat student. Okay, so this is what I would say a facet wrap. In terms of faceting, you have other elements that you can facet by. This doesn't have autocomplete. So if I do ggplot2 and then I do facet, there's facet grid where you can have a 2x2 grid based on 2 categorical variables. And there should be one more, but that's facet grid. Facet wrap, what this does, it has the flexibility. If it's like, let's say 5 different categories, like different majors, it would wrap to the next line if it spills over, if it doesn't fit the dimensions. So that's nice, little nice thing about facet wrap. Okay. All right, and so so then here, what we're gonna now do is do some additional, learn a little bit more additional aesthetics about plots. So here, if we were to look at this particular plot, it's not going to show. We can. I think I mentioned this before. We can just save it into a file, into a variable. So if I run this, I'm not going to be able to see it. But then if I do base plot, I'm able to now see the plot. Okay. So what I'm going to do is make modifications to this base plot throughout this video. Okay. So one of the things that we could do is, let's say we wanted to flip the coordinates. So we want to have weight on the x-axis and then on the y-axis and mouse per gallon on the x. There's this cool function called chord flip. I could see someone saying, "Oh, what's the utility behind that?" Chord flip. What's the utility behind that? I agree. You can just easily just switch x and y, but by convention, one could argue it makes the most sense to always have x be your explanatory variable and y be your response. Okay, this is a different plot from this, which is interesting. Okay, that's fine. So this is me flipping the coordinates. Okay, so if I were to take this out and then run it, you're going to see that they're going to be vertical now. Okay. But then adding that back, you see the horizontal. Okay. So that's a nice little function to have within ggplot. All right. So going back to the base plot, finally. So there again, not only is this a fast course, but at the same time, there's a lot of things I can't teach you because of time. So ggplot2 has a lot of different elements that you can work with. And one thing that you can change is the actual scale. You can actually change the scale of the categorical variable or even the quantitative, the numeric variable, based on all these different components. I think I'm only going to do one here, but if you remember that base plot, well, instead of having it be 4, 6, and where 4, 6, and 8 be these default colors, I can make it a different color. I can make it be, and you can do this on your own. You can make this. Oh wow, sorry, in quotes. Oh, it's not in quotes. Yellow. This is not. I'm not gonna do good, bad. I can make this red because yellow's not good because you can't see it. Orange. Okay, and then you can also make this blue. Okay, so you might notice I'm just adding this. Okay, I'm just adding this layer. Now when I add it, you can see it's a little different. Okay, so that is that. So something to note is that when it comes to this actual functionality, okay, the function called scale, because we're changing the scale, referring to the actual color, okay, that's the elements of the different colors, and then manual. This doesn't have to be the predefined color. They can be hexadecimal, so that's, you know, a nice little fix as well. Or if you have specified color, that's cool, so you can use that. What else? Okay, sorry. So then I think this is finally. It's got a little bit more things. Two more things. Okay, so we have to do a theme. So we can actually change the position of our legend. I know it's to the right here, but we can put it on the bottom. Okay, that's one thing that we can do. Put on the bottom. See, you see it's the bottom. Or you can even not even have it, if I can spell correctly. Okay, you can remove it. It's gone. So that's that. So theme, again, we already talked about axes. I remember I had that doohickey in week 1. Those videos, but theme has a lot of different functionalities that are possible within ggplot. So if you go here, oh, it doesn't give you this. Oh, because it's not a function. So there's all these different things that you can change regarding the plot. That is absolutely crazy. Okay, so just be aware of be aware that these things exist. Okay. All right, so this is a little interesting in that I think this is the last element, right? Second to last. Okay. Video's getting kind of long. You can take a break if you need it. This element here, in terms of labeling, we can put labels within our actual plot. We can actually put labels on cars in this, for example. We can put labels, the actual car names that we're working with. So if I just go label data, road names column, we had this problem last time. I'm pretty sure it's in tidyr. I thought I loaded in tidyr. Oh, it's in Tibble. That's what it's in. And as you can see, what I did, I'm actually going all the way up here to the top of the code. It's in Tibble. Okay. And then now, and look where I put it, because I wanted to put it with the rest of the libraries. Okay. Right here. Let's see. No error. Good. We go to label data. You have 2 rows. Okay. And so what we're specifying is that we want to label these 2 cars within the actual visualization. So now I'm going to have this geom text just take in this data, label data, and then apply it to, come on, mouse. Okay. That would have been a bit better if I just did label data. I'm going to do keyboard today, I think. Okay, label data. And now you can see it's labeled within the plot. So a couple things that you could ask me about this. One of the first things, like, why did I only choose these 2? Because it would be cluttered if I chose a bunch of different cars. Okay, that's something to note. Another thing is why would I yeah, I guess that's only one question. Ideally, just you wouldn't want to do it to every single car because it would be cluttered. You can adjust using this within geom text. You can adjust the actual vertical distance from the actual point regarding the text. We can also do HJust as well. If I spell it correctly, HJust is equal to -1. Okay. Oh wow, no, well that's not good. Let's make it 1. It's not gonna look good either if I do that. Yeah, because it's a long name. I'm pretty sure you can adjust the size as well. Size is equal to 0.5. Oh, it's really small. 2.5. Okay, so that's that. You can also see that it creates a legend, so that's something to note as well. And you can get rid of that specifically if you need to as well. All right, so last but not least, you can finally save your plot. So you can save it as, oh wow, the lights cut off because I'm not moving. You can save it as some file name. Let's say my plot. Actually, let's be more specific. MPG weight cylinder plot. Okay, that's fine. And then you actually put the plot name. And then run this. But then my question to you is, where do you think the file is going to be saved? Okay. If you took a moment and thought about it, ideally, it should be saved within, move myself, in the root directory. I believe it's going to be the root directory. Let's see. It is saved right here in the root directory, which is cool. Okay. I didn't highlight the actual code for this, but it's fascinating on the cylinder. That's cool. But how could you learn this on your own, or at least know it's going to be saved by this function called getwd? And getwd allows you to then see the directory that you're currently in. I don't like to change the directory, so I use the here function. But it's neither here nor there. Here or nor there. Well, thank you. This is a long one. I didn't know this was going to be that long. I just wanted to, and I didn't go on that many tangents, but we learned a lot in terms of visualizations. We were able to relearn, or at least get to see pivot longer and pivot wider. No, pivot longer in that left join, which was nice. And then we're able to, we did a factor reorder in terms of the plot. Okay, that's possible. We can see the utility behind the forcats. And who did more visualizations. Well, thank you and have a great rest of your day.